Hello, everybody. So welcome to this DataPorts session in the European Big Data Value Forum. So my name is Santiago Cáceres. I'm going to chair this session. I'm in fact the project coordinator of DataPorts. So just give me 1 second and I will share my screen. Okay, so I'm going to present briefly the project, and I will be introducing my colleagues who are going to provide demos in this session of DataPorts. Okay. We will appreciate if you have any questions, you can put it in the system. So we will be checking those at the end of the session and try to have a questions and answers slot. Okay. So for the moment, I will provide a brief introductions and introduce my colleagues that are going to provide details about the platform that we are developing in DataPorts. Okay. So first of all, I would like to set up a little bit of context of what we are talking about. So if you are thinking on European seaports, which is an infrastructure that may be familiar to you, there is a huge number of going to focus on the platform, which has been released summer this year as a major outcome of the project. I'm going to give you some headlines of the different components, and for some of them, you're going to have complete details in today's session, okay? So just very brief, you have here at the bottom of the screen the data sources and the raw data that they're going to use. So this can be shared directly to this data access component, or if you plan to share your data directly in chain in the blockchain network of DataPorts, you may have it. You have the access here thanks to this component. So the data access component in this case will help you to retrieve your data and will ease you the way to have your data inside the platform. Then we have the semantic interoperability, which will provide a common schema of the data for all the ports entities that are inside the ecosystem, and will give you tools to transfer this data to the common schema. Then we have the data abstraction and virtualization, where you will store your data and will be able to make preliminary transformation to your data needed probably for the analytic services for creating your artificial intelligence models, for example. All of this is what we call the data processing services. Then we have our data governance services. This is a technology that you are going to see right after my presentation, and it relies on a blockchain network, on Hyperledger Fabric, and we have here the clearing house for having all the logs of the platform, the IDS broker when you may have have a catalog of the metadata that is available in the DataPorts ecosystem. Then you have the identity management with the authentication authorization mechanisms, data governance rules, where data providers and data owners can specify who can access the data, for which purpose, during which time. Any restriction you may can be handled here through smart contracts. Okay, that would be the data governance services, and then the analytics services that are the ones that will help you to create models, so you can later on deploy to applications regarding situational awareness, predictions, forecastings of what's happening, okay, in the port. And on the top of the platform, to communicate with the outside world, we have the platform service gateway. So if you are outside your trusted environment and your trusted organizations, you may use of the IDS connector we are using here, the data space connector, which is published by Fraunhofer recently. Okay. So I will not extend more, and we wanted to show you today the DataPorts in action. So how this going to work at the end. Presentations are going to be short, about 9-10 minutes, and hopefully we will have at the end a brief panel discussion if we have time enough, with questions and answers from the audience. We will be checking the system of the Q&A. So if you have any question, please write down there. We will start with the data governance services that will be presented by Alexandros. Then we'll go through the data access and semantic interoperability that will be carried out by Andreu. The third session will be about the data abstraction and virtualization by Achilleas, and we will finish with the analytic services by my colleague Miguel. Okay, so so thanks very much. I'm giving room now to Alexandros. So please, you can take over control of the screen and start this set of demos of the DataPorts in action. Thanks.
Hello. Hopefully you can all see my screen and also me.
Perfect.
My name is Alexandros Zelidis. I'm a software engineer at CERT, the Center for Research and Technology Hellas, which is in Greece. And in the next 10 minutes, we're going to take a look at the data governance component of the DataPorts platform. Here we see the diagram of the DataPorts platform shown in the introduction, highlighting the data governance services. Data governance is a mechanism that enables the enforcement of access rules to business data assets in a transparent, verifiable, and non-reputable way. Data governance increases the consistency and confidence of in the registered data, all the while ensuring data sovereignty, and is based on three pillars: appropriate people. So, for example, a hierarchy of a chief data officer, a data governance manager, data stewards, and so on. Appropriate technology, for example, blockchain technology, and appropriate processes, for example, for data definition, discovery, and so on. Given these, data governance can provide data ownership, accessibility, security, quality, and the ability to easily extract knowledge. Sorry. Um, the technologies used in building our data governance component are shown here. We have a blockchain network based on Hyperledger Fabric. We're using the Fabric SDK for Node.js to expose our services. The ledger state database is CouchDB, and we write our chain code, our smart contracts in Golang. The data governance component follows the Hyperledger Fabric architecture model. We have a channel for data governance in which two ports are participating, the Port of Valencia and the Port of Thessaloniki. Both ports participate by having a peer on the channel and by each providing their own certificate authority and their own order node. Other organizations, for example, data providers, data consumers, can also interact with the network through a well-defined API, which the peers expose. The network can be extended with more peers joining the channel in the case that new ports would join the consortium. Now, participants in the DataPorts ecosystem can interact with the blockchain to perform any of these actions. So, for example, they can upload metadata of a dataset. They can define access rights to a dataset, search for datasets, request access to existing datasets. Providers can revoke access to a dataset, and they can also view the audit log of registration and access to datasets. And the diagram shows the hierarchy of these of the components used to build data governance. So on the bottom, there's the Hyperledger Fabric component with the chain code and the ledger. Then we have the middleware, which is built, as I said, with Node.js, which provides a REST API. And then we have a front end with which the users can interact and upload the metadata and define rules and so on. Finally, to end this 10 minutes presentation on data governance, I will show you a demo in which you're going to see the network and channel creation, the organization creation by the network provider, the organization administrator creation also by the network provider, the organization user creation by the organization administrator, an addition of a dataset in data governance, an access request on this dataset, and the acceptance of this request. So, without further ado, I'm going to start now the demo.
In this video, we're going to show how the data governance network is created and put to use. Setting up the network is done through shell scripts. First, the necessary certificate authorities are created, and then certificates are created for the admins and peers. Then comes starting the channel, creating the various peers, joining them to the channel, and so on. We then proceed to run the front-end web server. The view switches to show our front-end application, with the network administrator logging in. the network administrator proceeds to register a new organization, THPA, and its admin, Jane Doe. He adds all relevant organizational information and also the organization administrator's information, and proceeds to hit register. He then checks that the organization was indeed created and continues with the creation of the second participant organization, VPF. Again, the relevant information is entered for the organization and its admin, John Doe. And the administrator again presses register. He proceeds to click on the organization users to check that the new admin is present in the list of organization users. The network admin then logs off, and the VPF admin logs in with the credentials created by the network admin. She proceeds to change the password as obliged, and then goes to internal datasets, that is the datasets she owns, to upload a new dataset. In the metadata dashboard, she must fill in the required fields, marked by an asterisk, as well as any optional field she desires. By setting the access rights, she defines the rights that other users can ask for. Once all the metadata is entered, the admin submits the form. She then continues to select the newly created dataset from the list and looks at the details of the dataset, any permissions given for this dataset, its changes history, etc. Then the VPF admin logs out. Next, the THPA admin logs in and changes his password, as was the case with the VPF administrator. He views his organization's information, its registered users, and proceeds to register a new user for the THPA organization. He then views the internal datasets dashboard, which is empty, and decides to upload a new dataset. And submits the dataset. Once submitted, the admin checks that the dataset has been successfully added. The THPA admin then accesses the external dataset and sees that he is not authorized to access any external datasets. He does a search for datasets that belong to the VPF port authority. He chooses the dataset he finds and creates an access request. The available access rights for the specified dataset are read, write, and share, but the THPA admin requests only read and write permissions. And then logs out. The VPF admin logs in once more. He accesses the notifications menu, in which there is an access request from the THPA admin. She clicks on it and proceeds to accept it, being the data owner. So the request from the notifications menu is removed. Following, the VPF admin logs out and the THPA admin logs in again. He accesses the external datasets menu, where he views that he has been granted access to the VPF dataset by the VPF admin. He opens the Details tab, in which the metadata of the dataset are displayed. Finally, he logs out again. Now the video shows the THP admin logging in again. In reality, between logging out and logging in again, the system has been set up to contain multiple datasets, with permissions to each one having already been granted. So the THP admin accesses the internal datasets menu, he opens the details of a dataset, and views the permissions he granted for that specific dataset. Then he moves to the external datasets menu, he opens an external dataset, and views the permissions he's got for that specific dataset. That concludes our video presentation of the global data governance scenario.
And that's all from me. Thank you very much for your attention.
Good morning. My name is Andreu. I'm a researcher from the Universitat Politécnica of Valencia, and I'm going to show you the presentation about the data access and the semantic interoperability component of the DataPorts platform. From the service perspective of the DataPorts platform, the data access component and the semantic interoperability component are located inside the data processing services building blocks of the platform. These data processing services are exchanging data and metadata with the data governance services and with the analytics services of the platform. As an introduction, the data access component is basically a web-based tool to manage and run actions that integrates data into the DataPorts platform. And the semantic interoperability component provides a common API and a data model to access to the available data and metadata of the DataPorts platform. The data access component is the lowest layer of the DataPorts platform and is the component in charge of interacting with the raw data to facilitate and the data sources to facilitate the access to their raw data. This task is responsibility of the agents who are in charge of accessing to these data sources and converting into data models understood by DataPorts. In addition, this data access component offers a data access manager who manages the agents, who interacts with the API to run and stop the agents and manage all the information of the agents, to obtain logs about the events that happens in this part, or to create new, or to use a SDK to create new agents. The other component, the semantic interoperability component, acts as a middleware layer between the data access component and the upper layers of the platform. This component provides a common API and data model to provide access to the available data and metadata in a common format. And there are mainly two ways to access to the data. The first one is based in subscriptions, and the second one is focused in make queries to receive historical or near real-time data. Finally, this is the metadata registry, where we can obtain the metadata of the data sources available in the platform. From a technological point of view, there are several technologies selected to implement these two components, and some of them are specifically developed for the project. For example, the Data Access Manager user interface, the Data Access Manager API, or the on-demand component. But it's important to highlight the selection of the Orion Context Broker as core component of these two components, because this Orion Context Broker mainly offers alignment with the Connecting Europa Facility Digital Program. We can take use of the ETSI NGSA LD API for right-time digital twin data exchange. Now we are using the version 2 of this NGSA standard, but we are migrating to the linked data format, and we are going to move from the Orion Context Broker to Orion LD Broker. And finally, we are following and we are aiming to collaborate with the Smart Data Models Initiative for the description of data models. And now I'm going to present these two components in action in a brief demo. The aim is access to several data sources. For example, here we have the PCEs who provides information, in this case, of the Port of Valencia. Let me show you in English, about vessels, port calls, status. For example, we can consider other data sources like weather APIs to access to information of the weather or like dark sky. For that reason, this component can integrate and provide an interoperability API to access to these data sources. For that reason, here we have the manager of the agents, and the first functionality interesting is that this component lets you to create a new agent. Create a new agent implies to select the data source and the kind of data source, if you are going to access to an API, a local TXT file, an MQTT listener. And this set of possible types are going to be extended in the future. After that, you can select the type of agent. It could be under subscription or on demand. And the data model. Here, we are providing two examples, like a data model related with weather of the PCS. After that, you can provide technical details, for example, the URL of the API where you are accessing, the broker API, and select the entities, the attributes of the data model that you are going to create an agent. Then, if you push here and complete the fields, you can download a code that in few steps you can complete and have an agent. Here in this screen, you have some image of agents created using this template and Dockerized, ready to be used. For example, as I said before, there are two kinds of agents, public subscribe or on demand. Public subscribe are agents that are sending information via subscription all the time, and for that reason I'm running, or on demand that are waiting for a query in order to start, provide information, and stop. For example, here we can show in this screen the instance of two agents. One of these is running and sending information related with weather, and the other related with the PCS, who is waiting for be started. I'm going to start it. The agent starts, and then this agent sends the current information of the Port of Valencia. For example, here you can see the PCS real-time agent and who has sent the information of different vessels at this moment and following the data format. For example, in the other kind of agent that is related with the weather, it has been run during an hour and it's sending information each 5 minutes. For example, here you can see that these weather agents, sorry for that. Well, I'm going to provide an example here. This weather agent is sending information about measures in a location, about the pressure, humidity, and it is sending this information each 5 minutes. Fine. Here is all this screen is related with the management of agents. But if you want to know the metadata that you have available, you have this screen, and you can inspect the different data sources available in your platform, the data model of these data sources, and a short description. This is the metadata registry that is available to know the different data models that you have available in the platform. If you push here, you can see the Git repository who stores the data model of these entities stored in the platform. And finally, you can see the subscriptions that you have active in the platform. And for example, here there is one subscription that is registering the changes of the departure of the status of the vessels in the port of Valencia, for example. Sorry, okay. This is the manager of the agents and the data sources available in the platform, but you can access to it using an API, for example, to access to on-demand information or subscription information. In order to show how it works, we have created an example application that can receive, for example, in this case, notifications to these data sources. And for example, when a vessel changes its status, it is notified in this application. Or maybe you can do queries to obtain the current status of these data sources, for example, the current status of the PCS data at this moment in the port, or to retrieve historical queries that in different periods of time, you can perform a query and obtain all the information. In this case, not only the vessels that are now in the ports, finished vessels that are authorized, operational, you can receive all the information of all the events of the port. And the same happens with the weather, because you can obtain the information of one sensor, the sensor who is sending information, or you can receive historical information of the sensors. And you can manage all the information of your organization using this API and, for example, a tool like this one. And this is the brief demonstration of my component. And if you have any question, I can respond you after the presentations. Thank you very much to everyone.
You're muted, Achilles.
Hello, my name is Achilles Marinakis, and I am a research engineer in the Institute of Communication and Computer Systems associated with the National Technical University of Athens. In this presentation, I will highlight the next component of the DataPorts platform called Data Abstraction and Virtualization. The scope of this component is to correctly prepare all the dataset that were shown before in order to have the proper quality to be used by the analytics services in order to provide the cognitive application that a DataPorts offers. It also maintains useful metadata of these datasets, such as non-values, outlier percentages, and wrong values. And finally, exports those cleaned datasets to any possible recipient through RESTful APIs, focusing on quality of service attributes such as performance. So the overall goal of this component is to define mechanisms in order to facilitate data management and data virtualization. Regarding the position of data abstraction and virtualization component in the overall DataPorts platform, this component is part of the data processing services that the platform provides to the applications. In this picture is depicted the interconnection of the component with the other layers of the platform. As my colleague Andreu mentioned before, the component receives data from the semantic interoperability layer and the on-demand component in order to make its own processing and clean the data, filter the data, and finally expose them to the analytic services layer, which will be presented in the next presentation. Regarding the technological stack, the component consists of 3 subcomponents. The first one is the processing and filtering software, paths that it is developed using Python programming language and all the necessary package. The next one is the virtual data repository, the VDR, which uses MongoDB as a database framework, where we apply replication techniques and auto-scaling mechanisms in order to further improve the performance of the system. And finally, the virtual data container, which performs the final processing and transformation of the data, again, developed using Python programming language. Last but not least, in order to optimize the management of all the containers, the component lives within a Kubernetes cluster. After this short presentation, a brief demo will follow, where we will see how the component pre-processes 2 different kinds of data sets, and we will have a look at the generated metadata CSV files. After storing the clean data to the virtual data repository, then we will make real-time requests through the virtual data container in order to retrieve those data. So I will move now to the live demonstration. For that reason, I will use the Jupyter Notebook. I will run the commands in order to run in the parallel while I am explaining the functionality of the component. Well, as I said before, we will see how the component pre-process and cleans the data using 2 different data sets, one from the Valencia port community system data, which mainly contains categorical values, and one containing a Greek weather data, mostly dealing with numerical values. It is worth noting that our component is a generic one and can easily handles different kind of data with being semi-structured or structured. So I have triggered the command, and we see here the metadata regarding the Valencia port community system dataset. We can see here that we found some non-values, or here we see some wrong values, applying the rule that meaning that the departure timestamp cannot be before the arrival one regarding a specific vessel. So with this mechanism, we ensure that only cleaned and right values are being installed in the platform and being analyzed furthermore in order to produce AI services. And regarding the other data set, the Greek weather data set, we see here, for example, outlier detection, non-values detection, and again, we apply some logical rules in order to find out some wrong values. So, having stored in our virtual data repository the preprocessed and clean data sets, now we will make a real-time request to those data sets in order to retrieve a portion of those data, a data point based on some specific value parameters. For that reason, we have developed three different methods. For example, I will now use the first one, according to which we retrieve all the data, all the weather data regarding a specific year, in this case 2010. So I'm giving the request here, and what we will see as output is that all the data that appear here refer to this specific year defined by the user. I will try another method also. Here we will see, for example, how the outlier detection is working. For example, in this last row, we can see that the component detected an outlier regarding the average wind speed, and if we can investigate in the actual value here, yes, we can indeed see that it is an outlier value to be taken into account from the analytic services component in order to improve the quality of the cognitive applications. So this concludes the live demo and also the presentation. Thank you very much for your attention, and I am happy to answer any possible questions. Thank you.
Let me take control. Hello, everyone. I hope you can hear me properly and see my screen. My name is Miguel Bravo. I am from ITI, from Valencia. I am in charge of the development of the automatic model training engine component, which is within the analytics services umbrella. Yeah.
We cannot see your screen.
You cannot?
We cannot.
All right. Give me a second, please. I hope you can see it now.
Now it's okay. Yeah.
Okay. Thank you very much for the information. So you didn't miss anything, by the way. So I will continue where I was talking about. That's what I said before. What I did was to develop. We are in charge of developing the component called Automatic Models Training Engine, which is exactly located here in under the umbrella of the analytics services. And regarding the architecture and technologies of our components, first of all, I would like to say that this component is mainly focused on the development of cognitive services in order to by using machine learning algorithms and data management techniques. So that's the main goal of the component. And for that, this is the architecture we designed and implemented so far, as long as the technology is used for each of the parts. So the component basically is structured in the following way, where we take the data in a Parquet format files from the data abstraction and virtualization component. It will go to a distributed data repository implemented in Hadoop, in DFS. There is a subcomponent called machine learning pipelines, which will take the data from the repository previously mentioned in order to analyze, manage, prepare, and use the data for training machine learning models. For that, we use scikit-learn, Prophet, PyTorch, Flatin, and StatsModels library, common known libraries. And then those machine learning pipelines are implemented in the so-called distributed training engine subcomponent, which is supported by ITI proprietary development called Radiatus, which is a big data analytics as a service developed, as I said, by ITI. It will use Dask in the background in order to distribute not only the data, but the training models also. After that, and on top of that, we have a third subcomponent called training web interface, which I will show you afterwards at the end of the presentation as part of the demonstration, where the user, the potential user, will be able to interact with a component from the outside by using the IDS broker metadata. Once the machine learning models have been trained, the best one is selected, and it will be selected for the cognitive service, which will be available for the outside user to make potential predictions. Talking about the cognitive services, we developed so far the 6 cognitive services shown here. I will not go into the detail of all of them, of course, but I will talk about some of them in order to give you a brief idea of what we mean by cognitive services. For instance, all of them, of course, are related to ports, are port-oriented cognitive services. The first of them is the so-called Vexilar time of departure estimator. It takes the historical data, real historical data from the ports in order to make a time series prediction, an estimation of when a potential vessel coming to a specific port or terminal will depart in the future. The second one is the vessel port cost calculator. It will estimate, again, the number or the amount of vessel calls in a certain port along Europe. Or for instance, we have different services for predicting the amount of imports or exports of a specific product, which will go to a port of international port, European port, or coming to a specific port also. So it's a wide range of different cognitive services using data from ports. Behind the cognitive services, it exists the subcomponent previously mentioned called machine learning pipeline. This is the machine learning pipeline I was talking before, and what it does basically is take the data, prepare it, make some transformations, make a deep feature selection, and then the set of machine learning models I will tell you afterwards. Both standard machine learning and deep learning models, all of them based on time series, because that's the data we are dealing with in DataPorts. Afterwards, the user can also, or the pipeline can also make a models optimization by performing a hyperparameter tuning technique. And finally, the best model along all of them will be selected for the cognitive service. We will somehow have a best prediction possible. Talking about the algorithms of machine learning implemented here, you can see a brief introduction to some of them. As I said before, all of them are oriented to time series. Sarimax, statistical algorithms, Prophet, LSTMs, support vector regressors, etc. The user will also have the opportunity to configure the machine learning pipeline in different ways, in 4 different ways exactly: a fast pipeline, a fast training to get a model very fast, a standard training by using most of the steps of the machine learning pipeline, the optimum strategy, which will perform a model's optimization, and a deep strategy, which will use deep learning models, which of course will take the much more time than the other previous strategies. And as you can imagine, they are more complex models. Usually we will get quite good predictions, but will take much more time. And finally, I'm going to go to the demonstration of the web interface previously mentioned, as I promised before, which is this one over here. This is the web interface the user will have the opportunity to interact with in order to play with the component. In the first screen, we can see a list of already trained cognitive services. This is the name of the cognitive service trained, the description, when it was trained, and the status of it. If it's stopped, if it's a running service, or if it's a training cognitive service. The user will have the option to deploy it, to stop it, to get more information, to delete it. So it will have this versatility in order to interact with the component. This is the list of cognitive services. I'm going to show you how to create a new one. Here, the user will select the create label over here, and it will first of all set a proper name for the cognitive service. So in this case, we can type, for instance, DataPorts BDVA service. And the description, for instance, we're going to train one of the 6 already implemented cognitive services. We can implement the average Vexilar time, for instance. So, for instance, we will say average Vexilar time service 1 week prediction. That's what we want to try to train with the wizard. So we select the cognitive service previously mentioned. In the second stage, the user will have the opportunity to select which dataset they desire to use. We have data from Valencia port, marine traffic from Barcelona, and other places, other ports from Spain in this case. Let's try with Valencia port, for instance, and we can see the metadata over here, the description, a number of variables, route count, the size, and the last update of the dataset. So we will click next. In this specific service, the user will have a different specific configuration. The configuration of the service will start with a selection of desired port. In Valencia, we have 3 different ports: Valencia, Sagunt, and Gandia. In this case, we select Valencia. We also can select a terminal as a user, specific terminal, for instance, this one over here, and the time granularity of the service. So how much time ahead we will have the prediction. In this case, we said 1 week, so we will select 1 week in this case, and consider only the last year of training because it improves usually the predictions. Set configuration, and then we have to, as a user, choose the strategy desired. In this case, we want an optimum strategy because we want the best model possible. And finally, we will set a train service with the configuration parameters selected before. And as you can see, we have the service the user selected with the training status. So once trained, it will be ready here to be developed and make predictions. This is the end of my presentations. Thank you very much. If you have any question, please type it down in your systems.
Okay, thank you very much, Miguel, and all the presenters. So please, if all of you can switch on your camera for this final part of the meeting. So we have like 5 minutes left for our slot. And I would like to go through the questions from the audience. Okay, so we have one from Amin and Joshua. Hope I pronounced well the surname. And it goes after Alexandro's presentation. So he asked, could you please elaborate on how the off-chain data is shared? is the requester allowed to download it? So please, Alexandros, if you can take this question.
Yes, thank you for the question. Yes, once the requester becomes a consumer, meaning once the request has been accepted by the provider, then he can request the data by using an IDS connector. The IDS connector contains an endpoint, which is given and maintained by the provider. And the connector checks the permissions that checks with data governance about the permissions that the consumer has on that dataset. And if everything checks out, informs the provider, who then enables the connection, and the consumer is able to download the dataset. I hope this answers the question.
I think so. Thank you, Alexandros. So as we have time, one more question. It's for Miguel in the last presentation. So if we have a different port than the ones that are in the consortium of DataPorts for Valencia and Thessaloniki, can they use these cognitive services? How is it to use these cognitive services that you have been sold?
Hello, thank you for the question. Very interesting question, by the way. Yes, the question is the answer is yes. Any port from Europe would be could use the cognitive services implemented, as long as the data, the structure of the data is similar to the one we used. So the data will have to be aligned with the structure decided by and implemented by DataPorts. In that case, any of the cognitive services showed will be available for them to be used. Thank you very much.
Okay, thank you, Miguel. And Andreu, regarding this common data schema, so how does it going to work when the platform is completely available next year? So could you give us some views on this?
Regarding this common schema is going to be provided in a Git repository internal in the project, and it will be the DataPorts common data model. And now we are defining it with the use cases of the project. And our idea is, once we finish it and we have, how to say it, a stable version of this data model, start to collaborate with other initiatives in order to integrate this common schema with other projects. The aim of this schema is when we create the agents that we have explained, you can select this part of data model, and when you are taking the information from a data source and converting to this common data model, you have the parameters that you need to use as target to convert your information.
Okay, thank you, Andreu. And last question for Achilleas. So you show us 3 transformations needed to process the data. So are you planning to have more inside the project? Are you going to make this available in the platform? You are muted, Achilleas.
Thank you, Santiago, for the question. Yes, we're planning to develop even more methods in order to provide different data points to potential data consumers. But that will be happen depending on the data sets that we will have. We will investigate them. We will go through them, and given the requirements that we will have from the end users, we will develop those methods in order to provide the needed data to the data consumers.
Okay, thank you very much, Achilleas. So with this round of questions and answers, we can finish this session today. I hope for all the audience it has been interesting. You can visit our webpage where you will find all the information, our development portal also. You have there the emails of the people that we have been presenting today. So thanks to the presenters, and yeah, see you next time, and keep in touch if you are interested. Okay, thank you very much.
Thanks very much.
Thank you.
Goodbye.
Thank you. Bye.
Bye.
Ciao.